What is geometry? Meaning literally earth measure. Geometry began several thousand years ago for strictly utilitarian purposes in agriculture and building construction. The explicit 3-4-5 example of the Pythagorean theorem, for instance, was used by the Egyptians in determining a square corner for a field or the base of a pyramid long before the theorem as we know it was established. But from the 6th through the 4th centuries BC, Greek scholars transformed empirical and quantitative geometry into a logically ordered body of knowledge. They sought irrefutable proof of abstract geometric truths, culminating in Euclid's Elements, published around 300 BC. Euclid's treatment of the subject has had an innermost influence on mathematics ever since, so much so that deductive reasoning is the method of mathematical inquiry today. In fact, this is often interpreted as meaning geometry is two-column proofs. In other words, geometry is a formal axiomatic structure, typically the axioms of Euclidean plane geometry, and one objective of this course is to develop the axiomatic approach to various geometries, including plane geometry. This is a very important, though limited, interpretation of the need to study geometry, as there is more to learn from geometry than formal axiomatic structure. Successful problem-solving requires a deep knowledge of a large body of geometry and of different geometric techniques, whether these are acquired by emphasizing the proving of theorems. So Euclid postulates any statement that is assumed to be true on the basis of reasoning or discussion is a postulate or axiom. The postulates stated by Euclid are the foundation of geometry and are rather simple observations in nature. Euclid was a Greek mathematician regarded as the father of modern geometry. He is credited with profound work in the fields of algebra, geometry, science, and philosophy. Euclid introduced the fundamentals of geometry in his book Elements. So, postulate 1 says a straight line may be drawn from any one point to any other point. Note that this postulate tells us that at least one straight line passes through two distinct points, but it does not say that there cannot be more than one such line. However, in his work, Euclid has frequently assumed without mentioning that there is a unique line joining two distinct points. We state this result in the form of an axiom as follows. Axiom 5.1 Given two distinct points, there is a unique line that passes through them. So how many lines passing through P also pass through Q? So only one, that is the line PQ. How many lines passing through Q also pass through P? Only one, that is the line PQ. Thus the statement above is self-evident and so is taken as an axiom. Postulate 2. A terminated line can be produced indefinitely. Note that what we call a line segment nowadays is what Euclid called a terminated line. So, according to the present day terms, the second postulate says that a line segment can be extended on either side to form a line. Postulate 3 says a circle can be drawn with any center and any radius. And postulate 4 says all right angles are equal to one another. And postulate 5 says if a straight line falling on two straight lines makes the interior angles on the same side of it taken together less than two right angles, then the two straight lines, if produced indefinitely, meet on that side on which the sum of angles is less than two right angles. For example, the line PQ in figure falls on lines AB and CD such that the sum of the interior angles 1 and 2 is less than 180 degrees on the left side of PQ. Therefore, the lines AB and CD will eventually intersect on the left side of PQ.